Well, it's only one screen, so yeah.
Sharing the screen should be on your shot.
No.
Yeah. With the settings thing. Yeah,
There we go.
Okay. We knew we could do it. We were smart enough to use a hang. Did you switch your presentation? Is that everyone? All 10.
All right. So, so I'm Tom Crouse. I'm a Salesforce developer here at Trifecta Technologies. I'll be talking a little bit about the Lightning Component Framework tonight. Just a quick question to individuals in the room: how many people have already done anything with using Lightning components? Anybody? So we got about half the people, half, close to more. So first off, I just wanted to give a really quick example of a component exposed in the Salesforce One app. It does simple contact searching. So if we're going up to you can see we've exposed this contact search component, and this is built up from a couple of different components, each one with a specific purpose. One does text input and search, and then there is a separate component for rendering contact details, and another one for rendering a collection of those contact details. I think total development time on that was well under an hour. So it's really easy to get components built and working together quickly. So there is a lot that can be talked about with the Lightning component framework. We're going to try to squeeze as much as we can into a few topics in the time that we have. We're going to do a quick comparison, some key differences between Lightning components and Visualforce, the structure of the Lightning component bundle, and some core concepts for writing Lightning components. And we can, time allowing, we can delve a little bit more into the, like the source for the sample app that we have. So what is this all about? What is the Lightning component framework? It's a modern UI framework designed for building single-page web applications. It's currently in beta, has been in beta since its announcement last fall, but it has production quality features, so it is completely usable right now. It's mobile and desktop use oriented. You can design your applications for use on virtually any device, and the framework takes care of handling, abstracting some of the differences between there. An example being, you don't need to have separate checks for click events versus tap events. The framework will abstract all those into the same event. It's also built on top of Aura, which, if you're not familiar with, is Salesforce's open source UI framework. Apps within the framework are built using components. They're small building blocks of functionality that range from single line text output to huge sets of features, entire applications within the component. And they promote development with a focus on encapsulation and decoupling individual components. So for some of the differences between Visualforce and Lightning, Visualforce, which we've all used, maintains its state server side and is communicated between a page's server as a encoded and potentially very large string. We've all had wonderful experiences with. It's very page-centric, very heavy on server calls. Every action performed using standard Visualforce makes a call out to the server. One of my favorite examples of which being a check all checkbox that goes out and sets the check value out in the server. And then Visualforce will also often generate a lot of potentially excess code or excess markup. Makes extensive use of tables, and depending upon where Visualforce is used, it wraps your page within an iframe, making it difficult to communicate with other parts of the page, other parts of the interface. Lightning components, on the other hand, have moved maintaining the state over into the client, which allows for instant updates throughout the application as those values change in memory. And then calls are made to the server when only when necessary information is needed. You need to retrieve some additional data or perform an action, and the payloads, the data traveling between your component and the server is much less than what travels using Visualforce. Lightning components communicate through events, which again promotes decoupling, and they are much more mobile friendly than Visualforce, especially with some of the styling, the default styling that Visualforce supplies. So, quick overview of the component bundle. Go ahead and come out and just create your component by going to New Lightning Component within the Developer Console. Put a name and spell. And I already had that one. So you'll notice a bunch of different items listed over here on the right. These are the different pieces within your component bundle. The component is automatically created. It's the only required piece of the bundle. It houses your markup. Apart from that, you have the controller and the helper, which house your JavaScript. Style, which will house CSS rules that you define specific to your component. And those are the four main ones that you'll use, four most often that you'll use. Apart from them, there's also documentation, which is used for providing additional information, code examples for on how to use your component. Renderer, if you need to perform some custom rendering. Again, that's not the norm, but there are certainly cases for it. And then design and SVG, which I believe were just added in spring. And these two are oriented around making your component available for use in the Lightning app builder. So to go into a little bit more detail about each of those pieces, at least each of those four main pieces. We mentioned that the component is the container for your markup. It's the only actual required piece to be a Lightning component. It's where you will declare attributes, register events that can be fired by your component, declare event handlers, as well as include any other additional markup, whether it be additional components or just standard HTML. A couple of interesting things about the markup that you can include. Every individual HTML tag is treated as a first-class component within the framework. So it can take advantage of different things that are available to components. One important which is how you define local IDs on your tags. So for defining a local ID, you would specify, instead of just ID name, you would specify $ID and then give it your ID, and that makes it much easier to search for, much easier for the framework to search for that component. Every single component is also receives a unique global ID at runtime, very similar to the way that Visualforce generates IDs automatically if not specified. So expressions allow you to write logic within your markup. The syntax for them, or at least for starting them, is very similar to how you would do it in Visualforce: curly brace, exclamation mark. There's a large number of operators and functions available. Addition, subtraction, concatenation, if functions, and functions. And aside from, I think we'll come back here, you can see the ternary operator, CDF function. Apart from those operators, there are different value providers available for use within expressions. The two most common of which being V and C, respectively, for accessing items within the view and items within the controller. V gives you access to those attributes that you may have defined. So you can see an example here where we have an attribute named record of type sObjectAccount. To get the name off of that account, we would just do v.record.name. And then C is used for accessing controller actions that you defined in your JavaScript. So you would do C.function name. And we'll show some of those in a moment here. Quickly cover on some of the different kinds of Lightning events that are able to be thrown. If you're defining custom events, the two types that are available to you will be component or application, and the difference is just what components would be responsible for handling those events. So for a component event, the intention is that it's thrown by your component and it's handled by either the component itself or the containing component, a parent component. They'll register, we'll have an example of this on the next page. They'll register that they recognize that this particular event is fired and provide a handler for it. For an application event, and the only difference, again, being the value that you provide for type. For an application event, it's more the traditional publish subscribe model. Component announces that it can throw this application-wide event, and any component can subscribe to that event. And then when it is fired, it finds all handlers specified within that application and fires them all at once. Apart from those custom events, there are system events available by default, as well as Salesforce One events. Some examples of system events include the init event, which is fired when your component has finished initializing, or a waiting and or a done waiting, which are respectively fired when calls made to the server and when a call is returned. Those are you can write handlers for those, so they're very much the same way that you write application handlers. And then there are Salesforce One events that you can throw from your code, which are only available within the context of the Salesforce One app, but you can use to here create record takes you to the new record page, navigate to sObject takes you to the detail page for the provided record ID. For handling, here would be the syntax for handling component events. You see here, this would be an example of a handler for a component handling its own event. You'll note that the name has to match And then this would be an example of how you would register a handler if it's the parent component that's handling it. You would include it as part of the part of defining the child component, and then you just specify the handler as to treat the registered event name as an attribute. For handling application events, the only real difference between these two is the use of the event attribute instead of name, and providing the namespaced application event name. So the next piece of the bundle that we'll talk about will be the style. So you'll notice this is where you can specify CSS rules that are specific to just your component. And every single rule is preceded by this class selector, and that gets translated at runtime into a value unique to that instance of the component, and helps to keep your styles from bleeding out or other styles sneaking into your component or out of your component. The framework for styles specified in the bundle, the framework automatically takes care of vendor prefixes. But the one downside here is that these are all rules that need to be defined in line. They need to be, if you had styles that you wanted to reuse across multiple bundles, they would need to be multiple components. They would need to be copy and pasted. So if you wanted to utilize external style sheets, with Spring, they just released a new standard component, the require component, and it's the first one in this Lightning namespace. Allows you to specify a list of external style sheets or external script files that will be asynchronously loaded. It takes care of one-time loadings. So if this require component is included in multiple components, and they all load the exact same resource, it will only include it once. It also allows you to specify handler for actions to be taken after scripts have finished loading. It's worth noting that that's only ever fired if scripts are actually loaded. If you're just including style sheets, it's never called. The one trick here is that the namespacing that you get with this class selector is no longer available. So you need to manually, or it's recommended that you take care yourself of namespacing your styles. You would just precede every single one of your rules with some hopefully unique value, unique class name, and then wrap all the contents of your component in a div or something with that class name. So the next two pieces that we'll talk about will be the controller and the helper, the component controller and helper. And this is where you will include any JavaScript that you write. The controller is where you can expose actions and handlers, make them directly available to the component for use in expressions. It's just structured as a JSON object, named to function. It auto wires the framework takes care of passing in a reference to the component as well as to any event, and then optionally, if you want to include it, a reference to your helper file. And then you just write JavaScript from that point. If you had code that you wanted to reuse within your component, you can include it in the helper. The helper methods the helper is structured the same way, except that its functions are not available to the component. They're only available for use within other JavaScript files in the component, the controller, the renderer, and the function definitions are entirely up to you. For using Apex in conjunction with your components, you'd write your Apex pretty much the same, the same way that you would do if you're familiar with JavaScript remoting. This will look JavaScript remoting within Visualforce. This will look very similar. Any method that you want to make available for use within a component needs to be static and minimally publicly available, and also needs to be annotated with this R-enabled annotation. If you wanted to make use of custom types that you may have defined, a wrapper class or such, you'll note that any properties that you have on that class that you want to make use of in your component also need to be individually annotated as R-enabled, otherwise they'll be excluded from the result. To actually wire the Apex to your Apex class to your component, then you would specify in the markup a controller that you specify in your markup controller and provide class name. And this is where it gets this is where it can get a little confusing just referring to controller when you're talking about Lightning components. There's a difference between the component controller and the Apex controller, client side versus server side. And you can see down here, you can see in this image here how you would then actually make a call into the Apex from your controller. So you would, using the component reference, you would get an instance of your action. Here we had our Apex function in get contacts. You set parameters, which must match the names of the parameters. Specify a callback, and then enqueue the action. And it's one thing about making calls into Apex from components. They are processed asynchronously. So you just say, I want to run this action, provided these values, queue it up, and then it just gets processed in a callback that you provide then. And then that callback, you'll usually do some error checking, exception handling, and more than likely fire another event from there, like we're doing here. So from the component, we say, let's get this component event, provide the name as we have it defined in our markup, and then set parameters. You can have attributes within custom events, so set those parameters and then just fire it. So to make use of your new components, there's currently two main locations that you can actually use Lightning components. One of which would be within Lightning applications, and these are defined. These can be created through the developer console. New Lightning application, and for the most part, they follow the same bundle structure as a Lightning component. They can hold all the same items, have attributes, event handlers. It just acts as a top-level container that is URL accessible. So to get to it, you would go to relative to your Salesforce org. You would go to /namespace/bundlename.app for the sample that we have. That's just /c for the local namespace, and then context search that. An interesting thing about Lightning applications, it supports setting string attributes via a query string then in the URL. So if this were, type string instead of contact array, we could actually just pass in any value that we want for that. One downside to Lightning applications is that they themselves are not usable within the Salesforce One app. If you wanted to expose your functionality through the app, through the mobile app, your current non-pilot option is Lightning tabs, and what that'll do is it will expose. It's created through the regular tab setup menu. There's a section in there for Lightning tabs. You select a component that you want available, and then it appears as we see here within the navigation menu. Any component that you want to include in that has to implement this interface, the ForceApp Postable interface. And just I guess, a quick covering of the idea of implementing interfaces. Components support extensibility and compositions, so you can define interfaces that just have attributes. You can define components that can then be extended by other components, just like you can with Apex or any other object-oriented programming language. So coming or currently in pilot, or possibly coming out of pilot in summer, you'll also be able to expose your components for use within the Lightning App Builder, which is, we mentioned when we talked about, when we glossed over the design and the SVG parts of the bundle, as well as making them available as Lightning extensions, which will allow you to actually add on or override tabs and fields that are available from various pages within Salesforce 1. So some additional resources then that I would encourage you to go check out. There is a Lightning Components module available in Trailhead that is really informative. And then while you're at it, check out the rest of Trailhead, get points, get badges. You can also check out the Lightning Components Developer Guide. The first thing they start off with is a tutorial, building a Lightning component, and then they get into the documentation. You'll also check out the Developer Relations blog. There's, especially recently, there's a lot more Lightning component-oriented posts coming across. I think Salesforce U is doing a series of posts right now with online courses corresponding. Our own Peter Knoll has published, I think, a 6-part series on there about Lightning components. And then if you wanted to try doing this with something other than Apex, I would encourage you to check out the Aura framework. Again, it's open source, and right out of the box uses Java on the back end. So that's the end of my presentation. We can go into a little more detail on the contact search app if desired. As it stands right now, the app is just search by entry, and then it contains, since it's used within Salesforce 1, it supports navigating directly to the detail page for that record. Uses some standard components for exposing, for standard components for surfacing some values off of the returned records. And some of that source looks like, you guys want to see source, right?
Yes.
Yes.
Interested how it works. If you ran into any issues or any interesting things that you may have learned.
A couple of little things.
Oh, how fantastic was it?
Well, it's really fun to use. It really is.
Yeah.
So I mentioned that this app is composed of a couple of different components. The top part, the text entry, is just an input field and a search button. Context search. And it just uses a component controller and helper. Here's all the markup for that. It allows us to specify maximum number of results that we want returned. Registers a contacts found event, which is a component event that we have defined. Uses the standard input text available in the UI namespace. The code itself, for the most part, I think a lot of people write their controllers so that they just are as simple as possible and call into the helper then. So I tend to follow that pattern. For obtaining our entered value, this is where that Aura ID defined local ID comes into play off of the component. You can use find to search by that local ID, and it'll bring back that particular component. You can then do a get and obtain a value, or obtain some other attribute off of that component. So that's how we obtain our search text. Our record limit is obtained from the main component's max results attribute, and then it just calls into Apex our get contacts method, which you saw in the presentation, fires the contacts found event, which isn't handled by this particular component. It's handled in our parent component. Here. So we specify for the contacts found event that we want this particular handler to execute search results found, which simply gets the list of contacts out of our event and sets it for this component's attribute, this component's contacts attribute. And the neat thing about that is, as this attribute changes, here we have it pass through into our second component, our list component. As changes are made up here, it automatically flows down into this component and re-renders appropriately. So this contact list component is really just a iteration of another custom component that we had defined. Opening a lot of tabs now. It doesn't need any JavaScript. It's just another standard component, the iteration component, which we provide a collection of items. Looks very similar to Apex Repeat, and creates an instance of this contact detail component, providing it each individual record. And the contact detail component, which is as deep as this goes. Inception. So the contact detail component has a single publicly available attribute for holding that contact record, and we display the information off of that record. We display the name, phone number, email, NA if not there, and provide an on-click event for when they select that particular contact. And again, that on-click will get translated appropriately for whether you're using this on an actual mobile device or on a desktop interface. So our when clicked select contact will get the record off of our component, create a contact selected event and fire that off. And this would be an example of a component handling its own component event. When that contact is selected event is fired, we then call into NavigateView, which obtains the contact ID off that event, creates this standard Salesforce 1 event, and as long as that actually exists, then we proceed with setting parameters and actually firing that event. Otherwise, we just fall through.
So the reason that you fire this NavigateView event rather than just calling this code directly from the...
Well, you certainly could. Here it was for example. It was just to show a component handling its own event that it fires. You could absolutely
yeah, well, that was what I was going to ask.
Yeah, come out here and change this to on-click navigate to view, and then the code that you would use would actually be this down here. So
say you want to do multiple things on the click, and you want to catch it in multiple things. Is there an order how you can set it to handle these events? So we want to throw this event as clicked. And the first thing we want to do is update the contact or something. and then the next thing we want to do is navigate to it. But we have them in different handlers on the same event. Does it maintain order, or how would it figure out the order, or does that make sense?
Wouldn't mind repeating it.
So this contact gets clicked, which is going to fire off this NavigateView event, which if we imagine it's any other name, just like a click event that gets fired
Yeah.
off. And you have two event handlers on the same event. How does it determine which one runs first and which one runs second in the order of that? Because if you have the NavigateView run, and then you might skip the other half. Does that make sense?
I don't know. I hadn't tried adding multiple handlers for the same event. I don't know if you. I don't actually know if you can do that without trying that. Or whether or not, if it is possible, then whether it just fires them in the order that it appears within markup.
Okay.
So I mean, we could give that a try and see if it just blows up.
I could be wrong, but I thought I remember reading it was similar to like the Apex triggers where the order is not defined. So if you have something where you need to add multiple in some sort of order, you can create some sort of in between kind of broker.
You need to, yeah. Okay, that makes sense. You don't want multiple handlers for a single event.
Yeah. So if you have the application level, it's really a publish subscribe. I don't think it then calls out to the. I don't know that it's part of the API that it.
Yeah.
Publishes out to more.
Yeah. I was thinking, like, in this instance, you have a click, right? The first thing you might want to do is highlight what you click, which is its own component. Then you might want that event to bubble up to the parent and actually like put the name of the contact somewhere else. So, but if you have to handle it in one thing, you have to handle it at the parent and pass all those frames back through, which is fine. I'm just curious what would be the route to go.
So here it looked like it's firing them in order as defined within the markup.
Cool. Have you done all your development in just that console, or have you used NavigateView?
Pretty much. Maven's Mate has, or there is a plugin available for use within Maven's Mate. I haven't really used it, but I think I know other developers who have, and whether or not they have anything that they want to say, any recommendation for it. Peter.
It was I used it a little bit. It wasn't bad.
Okay.
Most of the stuff I had done was just in the developer console. It's pretty easy. You can click on that.
That side view looks really useful.
Yeah, the side view is really useful, and you can click on the button, so it goes to preview. And then as you're developing, if you make changes to the application, it reloads automatically.
Right.
The application file or component.
Yeah, so you'll see.
Bundle.
Yeah, you'll see. We already have our app open here, and if we go out and just add something like hello and save, it refreshes.
Very cool.
So that was the that's the markup for this sample. Are there actual development time? I don't think an hour. So
Wow.
I made a little additional time with some of the oddities that we ran into.
Oh, okay.
But lightning fast.
Like, how did you pick all this stuff up? Like, what did you do to learn?
Well, first thing I did was read the entire developer's guide. That's not necessarily enjoyable. Following tutorials, asking questions, putting questions on Stack Exchange, asking your local friendly neighborhood MVP. Trailhead.
They have a really good Lightning Components module, actually.
They do. And like I mentioned, the documentation, actually, the developer's guide actually starts off with, okay, we're going to walk you through building a component. instead of you know, a ton of dry documentation right off the bat.
Actually, two questions.
Yeah.
One pertains to CSS. So is there any notion of like a default style sheet? Like let's say, like if we Visualforce, you don't specifically put any kind of style in there, you get the out of the box Salesforce. You get that? Is there any kind of default? And I know the Lightning components that have their own, like Salesforce will have their own
Yeah.
look and feel. So if you don't define styles for your stuff, you get the default look and feel for that, or is it basically
Default like
old
Salesforce 1 look and feel? No, it's just plain old HTML styles. And then as far as, you know, like the differences in appearances by using standard components, again, those are styles that are encapsulated to, yeah, they bake them directly into the component. So your components can look and feel however you want. There are, I mean, there are style guides out, and they've been out since you could do custom development in the Salesforce 1 app.
Tracking the style. One thing that's interesting is you can extend components. You can if they design a component that is extensible, you can actually create a component that extends it and add some actual functionality to it.
Create an entire hierarchy like you do with, again, with other languages like Apex.
Yeah. It might not always be the best solution, but yeah.
Complexity.
Pull like a controller code and stuff in, or just do the actual markup? How would you extend markup? Yeah, there's a decent amount. There's a really long answer to your question. But yeah, okay. Yeah, there's.
It's talked about in, I mentioned Peter has a series of blog posts out on developer relations. It's talked about in there.
There's a special attribute called body that has a special way of inheriting, and then helpers are inherited, and events are inherited, and then you're not supposed to call the controllers for inheritance. Although I think technically you can, but they were talking about removing that. Okay. And you're supposed to any functionality inheritance is supposed to be done to the helper. You can call it super helper, or you can make a call without calling super, and it'll automatically use the super. So, and I probably didn't explain how the markup is inherited, but there's a special body attribute. Okay.
I guess one other quick note that's on everybody's mind, that's on every developer's mind, is unit testing. So there's currently no enforced testing of Lightning components. I thought there was talk of introducing some support, some framework for being able to test your controller code, but whether or not anything has yet been finalized on whether that will be enforced code coverage, I haven't heard it. I haven't heard anything. You still have to write code coverage for any Apex that you use with your component, but there's no escaping that. One nightmare.
Actually, my other question was around the Apex. So if you have an Apex mounted that's already enabled, I'm just curious, do you know if it is that because it's technically executing asynchronously from that amount of fires, does it get treated as an asynchronous request in Salesforce? It's still a synchronous request.
As far as counting towards limits, I don't think it counts towards limits at all. I think it's, again, like similar to behavior with JavaScript remoting. JavaScript remoting doesn't count against API limits. It's just execution time for your Apex. So as long as your R enabled function completes within 10 seconds.
Right.
But no, I don't think it has any impact on API limits. Yeah. Any other questions? All right. Well, thank you.